welcome to another of our classrooms here, or series of tutorials and speakers and conversations. Today my guest is me, and I want to talk about an introduction to electronic flash. So a lot of this might be kind of basic for some people, but maybe you haven't used flash much before. So let's see where we go with this. We're going to cover a number of topics today. Watt seconds, speed rings, triggers, meters, colors, synchronizing, power settings, not in this or any particular order. First, I want to say we've come a long way. This is an ASCOR flash system from the 1940s. I think there's people still actually using them today. Each of those gray silver boxes is a capacitor. It's 800 watt seconds. It's filled with oil and weighs about 60 pounds. But you can put like 30 of them together for like 48,000 watt seconds of light. So when these flashes go off, the rest of the city dims. Compare that to what I'm using here today, a little 4-pound Interfit Badger Unleashed. Okay, it doesn't put out 40,000 watt seconds, but it does its job. Back to the ASCORs, they were considered portable at their time because one person could move them around on wheels. And they're called speed lights, which we generally use as a term for small camera flashes these days. So as you can see, you can build all different configurations. The one at the bottom there, the control panel alone weighed, I think, 375 pounds. So we had a much different feeling of what was portable back then. Again, we've come a long way. Here's a bunch of strobes that I've used over the years. There's a Speedotron pack and head back there, and a Dynalite, an Interfit, more Speedotrons, some an Einstein. I've been through a lot of these things. And let me just say, strobe is a misnomer. Strobe implies multiple flashes, but it becomes a habit that we call studio flashes strobes. So if I call them strobes during this, forgive me, but I really want to say studio flash, 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 not strobe. So light is light, be it the sun, a light bulb, a flash unit, they all emit light and we can modify them as needed to do what we want to do. You got the properties of the flash are that it's daylight in color, it's consistent, it's controllable, and we can use it just about any time and anywhere, unlike the sun. When we're looking to purchase a flash, we want to know, is it bright enough to give the exposures that we want? Does it render colors correctly? Can it light up the subject the way we want? Can it stop motion? Do you need it to stop motion? And can it recycle quickly so you can take shots in a row? So traditionally, there have been packs and heads where you had one major main power pack where all the heads plugged into, and you controlled everything from there. The power pack would have 2 or more outlets to plug various heads in via cables, but now most of us use monolights. Each of them have their good and bad points. Packs, let's see, the packs allowed for smaller and lighter heads, so if you're putting things out on boom arms, the light heads really helped. If one light went out, you can replace just that head. But if the pack went out, all of your lights were out. Everything was controlled from the central location, as I said. But with monolights, each has to be adjusted individually. But now we have remote controls on our cameras that can take care of all those things. So I think pretty much the future is in the monolights. And then there's watt seconds. One of the first things we think of studio flash is how many watt seconds. That could be good or bad. I'm going to give you a quote from a 1950s magazine article on electronic flash. I think you can read it on the screen there. Because really, what are watt seconds? Can anyone answer that? Just think, it tells us how much energy is stored in the flash capacitors. It has no bearing on the output. I mean, more watt seconds, more output. But if you take a light from one company and a light from another company, they're the same watt second rating. They may be different power flashes from them because it doesn't take into consideration the efficiency of the whole system, what cables are used, the design of the flash tube, the electronics. There's all sorts of stuff that contribute to the actual output. So watt seconds really is not that great a comparison, but it's pretty much what we have to go by unless you can put things side by side to try them out. So most lighting systems now use a numeric system for setting the power, but some use fractions. So on this light, for example, goes from power 2 to 10, so a range of 9 stops. Each full number is 1 stop more or less than the next. Let's see. You can also dial in 1/10 stop increments for fine control. As I said, speed lights and some newer studio flashes use fractions like 1 full power, half power, 8 power, 64th. They also usually like you dial in a third of a stop increments. These numbers are pretty much arbitrary and only relate to other numbers on the same flash. They don't account for the modifiers of distance. So say you had 3 lights in your setup and there are different power ratings. Maybe you had a light that's 200 watt seconds, another one is 300, and the third is 500. Saying that one light is half power and another one's a 32nd power, another 64th power, it's pretty much meaningless, especially if they each have a different modifier and are different distances from the subject or whatever part of the scene they're illuminating. It's always frustrating for instructors because people are always asking what the settings were for a photo. The settings are what was appropriate for that particular situation. It's not going to help you figure out the next situation. So as I said, the numbers, they could be numbers or fractions, and the numbers can look like f-stops, but they have no relation to f-stops. So here we have one that's set at power level 5, 6, which looks like an f-stop, but an f-stops, what stop either side would be f4 or f8. And power levels, they'd be 4.6 or 6.6. When looking to purchase, you also want to look at how far the flash can be turned down. Sometimes more important than how high it can be turned up. Many times if you want to shoot wide open, your flash doesn't power down enough and you either have to add diffusion or neutral density filters or any number of other things to lower the power of the flash. So make sure you can turn it down a lot. So little quiz. If you've been in a couple of the past classes, we've had the same quiz come up. So if your flash has a power setting of 2 to 10 and you're set at power level 10 and you want to cut the power in half, what number do you set the flash to? If you're full power and need an extra stop of light, how many flashes do you need to add to get to that extra stop? And if you need another additional stop, how many flashes do you need? So let's go to that first question. If your flash goes from 2 to 10, you're at 10, you want to cut it in half, what number do you go to? Anyone have an answer?
It should be 9, I think.
Yes, okay, good. You passed that one. Remember, each number is 1 stop. So if you're comparing a 500 watt second light to a 250 watt second light, the 250 is the same power as the 500 at set to 9, not set to 5. If it was set to 5, you'd be 5 stops below the original power level, or 1/32nd power. So if you're full power and you need an extra stop of light, how many flashes do you need to add to get the extra stop? You need to add 1 more, so you have a total of 2. If you need an additional stop, then you need 4. To double the output, you always need twice the power. Fortunately, most flash units today can provide enough light for today's cameras, and today's cameras can use higher ISO settings. So it's often more important to find out how low a power light can be set, especially if you like to shoot wide open for limited depth of field. So here's a little chart that compares the power levels with the fractions and 2 flash units. So I hope you can see that telling someone the light was set at power level 4.7 or at 1/32nd power doesn't really mean anything. If you want to tell someone how the lights were set, use a flash meter and tell them that the main light reads F7.1, the background reads F9 or whatever. You know, we'll talk more about flash meters in a little while. Gets confusing because their cameras can be set to operate in half or third stops. I have my camera set to 1/3, my lights are set to 1/10 a stop, and my meter set to 1/3 a stop. You'll get used to it after a while. Shutter speed I use in the studio is almost always 1/125, and I'll talk about syncing in a few minutes. So here's my little nerd humor. Back in the old days, you'd say if the setting was between 8 and 11, it would say it was 8.5. But now that the strobes display the full numbers in between, 8.5 is equal to 9.5. Anyway, just my nerd humor. You can just ignore that. So flash synchronization, what's going on there? Most cameras today have a focal plane shutter that sits right in front of the sensor, and it operates by sliding curtains, for lack of a better word, across the sensor to allow light to reach the sensor. In normal flash photography, the shutter speed on the camera has no effect on the flash exposure. The flash produces a bright momentary flash that is quicker than the camera shutter. So let me demonstrate that. So if you take a photo with no flash, you see how dark this scene is. If you then take the flash at a 1/5 of a second, a 30th of a second, or a 1/60th of a second, if you're not in a bright environment, you're not going to get the ambient light is not going to affect the exposure. It's all going to be from the strobe. So if you go above the sync speed, part of the photo gets cut off by a black line. And unless you have a feature tool called high-speed sync turned on, we'll talk about high-speed sync a little bit later. It's kind of beyond the presentation today. So that's how you end up with this dark band at the bottom of the photo. So let's give a demonstration here. The shutter opens, the flash fires, then the shutter closes. So again, shutter opens all the way, the flash fires, and then it closes. But what happens if you're out of sync? If you go above the sync speed of the camera, curtain opens, the second curtain starts to close, then the flash fires, and we only get part of the frame exposed. So let's see that one again. So here it is in linear form. So then there's also something called second curtain sync or rear curtain sync. Let's mention that one. With longer shutter speed, so maybe in 1 second, you can have the flash fire as the exposure starts, or you can have it fire as the exposure is about to end. So I've got it at 1/25th of a second, flash is in manual mode. And now I'm going to put the Rebel to 1 second. And again, the flash fires, then the shutter stays open and then closes. But if I put the camera, the flash now into second curtain sync, you're going to hear the shutter open, and then the flash goes off at the end. So again, shutter opens, flash fires at the end. So it makes the subject blur go in front or behind the subject. For the first curtain flash, it often makes the subject look like it's moving backwards. To make it look forward moving, we use the second curtain sync. So there you see with normal or first curtain sync, the shutter opens, the flash fires immediately, the subject blurs in the ambient light, and it looks like the subject's moving backwards. The second curtain, the shutter opens, the subject moves and blurs, then the flash fires. And how do we sync our cameras to our strobes? Let's move that out of the way. There are a few ways to do this. Radio triggers are the most common these days. Most cameras no longer have a port to connect a sync cord to, and sync cords were always very unreliable. They're always breaking. So another option is to trigger one light from another using optical slaves. The issue here is that TTL, where the flash fires twice, that usually won't trigger the cell correctly. I'm on second curtain sync, and let's go into ETTL mode. So you can see that there's a pre-flash fires, then before the shutter opens, and then the shutter opens and the real flash fires. So what happens with the slave is that first flash sets off the slave, and then it doesn't recycle in time for the actual photo to be taken. So you don't get any flash affecting the exposure. So let's turn on the cell here on this light and you can see what's happening. So my cell is on. If I take the shot, the first flash fired the strobe before the shutter opened, and then it doesn't recycle in time to get the real shot. So that's why TTL and optical slaves don't get along. I hear there are some slaves that could be programmed to ignore that pre-flash, but I don't really know much about those. Then there's triggers for your flash. They sit in the camera hot shoe, and you can change the controls on your flash. You can change power levels, you can turn off high-speed sync and through the lens metering. Remotes can introduce a short delay to the signal going to the camera to the flash. So that's another reason why I'd never shoot at the high sync speed. I always try to lower it. So usually I said, I think it was about 1/25 of a second. Then we have the flash unit itself, as you can see here. The channel and group let you put the lights on different channels or groups so you control things like power separately. The mode sets the HSS on or off. Beep lets it make a sound when the flash is recycled, so you know if you can't see the recycle light. So let's turn the beep on, and when we press it, and if you turn the power down, you can recycle pretty quickly. So let's go all the way down and see how. Color temperature. What about color? Our eyes and brain work together and interpret colors correctly in real life. We know what a white sheet of paper should look like, or a red flower, or an orange. If we change the color of the light source, we still see red, white, and orange. Cameras don't quite work that way, nor does our brain when we look at a photograph. Flash is on the bluer end of the color spectrum, but it is full spectrum, so we get good color results. Think of outdoor lamps like sodium mercury or mercury vapor street lamps. They have a limited spectrum and don't show any colors accurately. Flash color can vary, though, at different power level settings on your flash. For accurate color, use a gray card made for white balance, not a gray card that's printed, because printed cards come off a printing press and the color can vary. They're just really set for exposure, not their color. But there's always the color checkers, like the color checker passport. You set your lights and exposure, then place the gray card in the scene and come in close to fill the frame. The image doesn't have to be in focus for this. Take a photo of it, then use that photo to set a custom white balance. And how you do that's going to depend on the camera you have, so we won't go into that. Shooting in RAW format lets you change color balance easily in post-processing. So here's how I tested my light. So I set up a scene with some objects of different colors and some neutral grays. Then I took a photo at each power level, adjusting the lens aperture to maintain the right exposure. Then in Lightroom, Camera Raw, Capture One, or whatever, see how much variation there is in the neutral grays from one frame to the next. Here, there's pretty much no variation except for the very lowest power setting. So it was pretty stable throughout this power range. Another thing to do is test all your different modifiers. You'll find that different modifiers can add color. For that one, you want to set the light to one power level and keep it at the same power level, and then shoot with each modifier. As you can see here, the shoot through umbrella is a little more blue than all the other ones, and old softboxes may have yellowed over time. You can use the color checker passport to get accurate color, but accurate color is not always pleasing color. I mean, you want accurate for maybe fashion stuff, for makeup, for food, but if you're doing portraits, we often want to change the balance, white balance, and make it a little warmer. As I said, accurate color is not always pleasing color. So I also said shoot in RAW format if you want post-processing control over the white balance. Here's a photo made at the wrong white balance setting. It was set to tungsten when it should have been daylight, and the photo made at the correct white balance setting. Here's the RAW and JPEG versions of the image at the wrong white balance. And then going into Photoshop and Lightroom, I try to correct for each one. And the middle one's the best I can correct the JPEG. And over on the left, you can see what I corrected. The RAW can match the original that was shot correctly. So you have much more latitude when shooting RAW. Then we come to light meters. Again, we've come a long way. Look at the light meter this guy's holding in the 1950s instruction manual. So meters are reflective versus incident, camera versus handheld. Where do you point the meter, and how do you sync it with the flash meter? Your camera looks at a scene and measures the light reflecting back into the lens. Handheld meters can be pointed at the subject, or it can be held at the subject pointing at the camera, which is called incident metering, and that tends to be more reliable. You point the meter at the light you are measuring, not at the camera. If you point it at the camera, it averages the contrast across the scene, but if you want to get a reading specifically for that light. So if I was being lit from over there, I'd take the meter and hold it. Let's grab a meter. That's held toward the camera. That's held toward the light. So I would read towards the light. As with the cameras, there are many ways to sync the meters. Some have radio transmitters, some connect via a wire, and some wait to see the flash. They're all valid methods. So let's demonstrate some of those. So first I'm going to do open flash. I set my meter, I set it to open flash, and it waits to see a flash. Gives me F1.4 there. Second is with a cord. So we've got a PC connection cord on the side here, and that can plug into the meter. And then we'll set the meter to corded function. And there, I fire the flash by pressing the button on the meter. And the third way is by putting something like a pocket wizard on the flash with a transmitter built into the meter. So again, let's plug that in. Here's my pocket wizard. Set it to receive mode. Then I set the flash meter to transmit mode. And now with no wires, I can fire the flash. So there's your various ways of triggering the flash to work with the meter. TTL means through the lens. The flash fires twice when you're using TTL. I think we saw that before, but we'll go over that again here. So on a DSLR, you can sometimes see the first flash through the viewfinder while the mirror is down, so you know that's not affecting the actual exposure. The light isn't hitting the sensor on that. So let's look at this again. Got to put a remote, manual mode, TTL, second curtain sync, 1 second exposure. So let's go to, I said manual mode. And go down here. So again, the flash fires, TTL sets it off, and it doesn't show up for a real exposure. So you got to watch out if you're using TTL and optical slaves. TTL is usually pretty reliable, but can be tricked by overly bright or overly dark situations. A lot of times, if people don't have a meter, they'll use TTL to get the exposure set and then turn it to manual and leave it at the same flash power and keep going from there. So that's a way to do it if you don't have a meter. HSS is a little beyond the scope of this presentation today. It's usually used outdoors on bright days when you want to shoot at a large aperture and can't get the shutter speed low enough to sync with the flash. Basically, HSS lets the strobe sync at a higher shutter speed by flashing rapidly to simulate a constant light source instead of a single flash. It does not help with freezing motion. So here we saw this, the top two before, and now I've added this other simulation at the bottom, which shows what happens with high-speed sync. As the shutter curtain is moving, the flash keeps firing rapidly with it to keep up with it. So I'll show you what that looks like. So you can see the flash here looks continuous, and that's what's happening with high-speed sync. So the flash looks to the film or to the sensor like a continuous light, which allows motion blur. So when you're using high-speed sync, it also tends to lose a stop of light for each doubling of the shutter speed. In normal flash photography, the shutter speed doesn't affect the light output at all of the flash, but with HSS, it changes with the shutter speed. This could be a drain on the battery and a burden on the flash tube, as you saw by those rapid flashes. So here's my 430EX with a fan. And you can see in the first image taken in continuous tungsten light, hence the yellow color, there's no flash at a 15th of a second. The fan blades are totally blurred out. Across the top, you see the same shot using normal sync at a 15th or 1/25th. In each, the flash is frozen, the fan blades. The last three shots are in HSS mode at a 400th, an 800th, and a 1600th of a second. None of them were able to freeze the blades of the fan. So I just wanted to get the idea that high-speed sync is not for stopping motion. I did the same thing here with the Badger Unleashed, At 1 sec exposure in a dark room, the fan blades are frozen with normal sync. At high sync, I had to go all the way up to an 8,000th of a second to come close to freezing the motion. For stopping motion, we have to rely on the flash duration of the flash. And if you look at the specs on flashes, they often list a T5 and sometimes a T1 rating. T5 is not really reliable because it says start measuring the flash when it reaches a halfway power and then cut off the reading when it reaches halfway down again. But you still have the tail of the flash that's going to allow things to blur. If you read the T1 duration, that says start reading at 10%, go up to full power and back down to 10%. So there's pretty much no light outside of the T1 range to make the subject blur. Let's see, modeling lamps or focusing lamps. As the flash is momentary, you can't see what it's doing. So a studio flash units add a modeling lamp to try to simulate what the flash can do. They're not always totally accurate, but we can see one here, so we can turn on the light. And modeling light can be set proportional so that it goes up or down with the dial of the power, or it can be set to be always at full power. As I said, it's not always accurate, so I usually just keep them at full power just to help with focusing and rely on the modern Polaroid or the digital back or the tether to see if I need to adjust lights up or down. Let's see. Some units have hot incandescent lights, so be careful if you're using them with modifiers, especially enclosed metal modifiers like a snoot or a spotlight. They can overheat. A lot of those units have fans in it, but still a 250-watt quartz light gets really hot. And if you do have a quartz light in there, don't touch it with your fingers. The skin on your oil will boil on them, and they'll eventually fail and possibly explode. This one uses an LED modeling light, which is great. Never heats up more than 80 degrees F. Light modifiers. Flash units can be fitted with a large variety of modifiers. I've done a few classes on modifiers on YouTube, so if you want to find out what the different soft boxes and the light do, please go look at those. Instead, I want to talk about here how to attach modifiers to your flash units. These are done with speed rings. Speed rings are pretty standard, except that the outer ring could be 4, 8, or 16 rod holes. So let me grab some over here. Speed lights can be the greatest invention, or they can be a royal pain at the same time. They're great because you can change systems out and use the same modifiers. They're a pain because the inserts come in different sizes, and they can be difficult to assemble with your modifier. So you get the speed ring, the modifier attaches to the outside, and then an adapter ring attaches to the inside, and that attaches to your flash. However, this inside ring is not standard. As you can see, they're not all the same. Here's basically how to assemble a softbox. You put the rods into the corner pockets and bend them around and get them into the speed ring, which can be a real pain on some, especially strip boxes tend to be really hard to put together. Some are more difficult than others, but luckily many modifiers now come in foldable versions that just set up like an umbrella. But here's a little demo of quick release speed rings that will help you along if you're willing to spend a little more on the speed rings. They do make life much easier. And then there's large modifiers. Sometimes the modifiers are too heavy for the flash and tend to make it tilt over. When that happens, you may want to use what we call a yoke. So let's make believe this is our super heavy modifier here. So I've attached the modifier to the yoke. The yoke's attached to the light stand. And then the light attaches to the yoke like so, and then it's all one unit, and you can tilt it everything is supported by the light stand, not by the light and not by the modifier. So our final topic is coming up. I hope you stuck around, and that's the inverse square law. And the inverse square law is a law that says I have to talk about inverse square. So let's get into that, and we'll go into some questions. Basically, it says that the brightness of a light changes more rapidly than you might expect when you move it closer in or further from your subject. So if you move your light in from 10 feet to 5 feet, half the distance, you might expect it to be twice as bright, but it's actually 4 times as bright. If you double the distance, the light doesn't get half as bright, but closer to a quarter as bright, as the photons from the light are spreading out in multiple directions. So let's see if there's maybe this picture here will help. So at 2 feet, the light covers 4 times the area. Then if you double that to 4 feet, it has to cover, what is that, 16 times the area. So basically what it comes down to is knowing that the closer your light is to your subject, the darker the background's going to be. I'll leave that up there for a few seconds if you want to read through it. Here we are, questions. Feel free to unmute and join in.
Well, I will say that the difference between T1 to T5 is, to a large extent, what made me consider different lighting brands than others, and explain some of the cost differences.
So what are you using now, Ian?
Broncolor. Although I've used ProPhoto, and I own ProPhoto, and ProPhoto is great too. But yeah, for various reasons, I ended up going Broncolor.
Yeah. Other questions or comments?
Hey, John, so
Yeah.
there are times when you'll control the flashes, by walking over to the light and adjusting it. And then there's times when you might be controlling it remotely. Is there, I guess when you're in the studio, do you just mostly don't need remote control, or what's the trade-off there? Or just, when you use one or the other?
The trigger is great because you can put if you have multiple lights, you can put it on different channels. So I can say light 1, my main light's going to be at a power level 5. My rear light's going to be a power level 3. And if I decide I want the rear to go to 4, I can just change that one from the remote. I don't have to go to it to change it. So let's see if I can.
Is the remote coming from the same manufacturer as the light, or
yes.
are they?
Yes, they're particular to a light. So the intermittent remote won't work with ProPhoto, which won't work with Godox, which won't work with Ellen Chrome. But I can fire the flash from here. Let's see if I don't know if you can read the numbers on the back, but let's just turn them on the light. Turn the beep on and off, and I can raise the power. So let me get so you can see the numbers changing from here as I'm pressing them on here. Let's turn that beep off.
That's basically an optional accessory you can choose to buy or not.
Yeah, I mean they're not that expensive. They're less than $100 for most lights.
Yep.
It just gives you that control. Other questions about what to look for in a strobe, or there, see, I call them strobes, and a flash.
I think one of the things that you should also consider is customer support. And which is also one of the reasons I've always stuck with ProPhoto and Broncolor. Just superb support.
Let's see, this week on Thursday, my guest is going to be Jen Rosenbaum, boudoir photographer, cancer survivor, and I'm really looking forward to that one. Hope you all can join me there for that. If there are no more questions here, I'm going to kind of shut this one down.
Thank you, John.
Thank you.
Thank you.
Have a good day.